All right, I'd like to go over really quick some of these questions that are on the top of our paper. And we're asking about forces and motion. Let's go to a different slide to see this better. Okay, the first question we want to go over is we want to describe motion when forces are unbalanced. Okay, unbalanced. So let's imagine we have a box and it's on a surface and it's just chilling here. It's at rest. Now, two forces are going to be acting on this box. You are going to be pulling this box this direction with a certain force, represented by the arrow. Doesn't matter what the number is, we'll just represent it by the arrow. And your friend is pulling in the opposite direction with a certain force, represented by this arrow. So the forces are different because the arrows are different sizes. Now let's make a prediction. What's going to happen when you are pulling and your friend is pulling in opposite directions, but also with different forces? Well, we're going to have movement happen. So you're pulling with a stronger force, and so overall the net force would move the box this direction. So the box will move. What happens is the box is going to change its velocity. It was at rest and then it begins to move. So that's what's going on. The motion is going to experience a change in velocity. And the word for this we use is acceleration. So the box will accelerate when the forces are unbalanced, and any object that experiences unbalanced forces will accelerate. We know these forces are unbalanced because they're different. If these forces were equal and opposite, the box would stay at rest. Now let's say we need to calculate acceleration. Okay. In order to calculate acceleration, we need a couple things. We need some information about velocity, and we need some information about time. So we need to look at how our velocity changes over a period of time. Okay. Now we can make these a little bit more detailed. Change in velocity is equal to our final velocity minus our initial velocity. And change in time is equal to our final time, our final time minus our initial time. So if you wanted to calculate acceleration, things you would need are these, okay? And as you calculate your acceleration, you'll be able to fill in the table that is on this first page.